Good afternoon. Thank you for attending to this webinar organized by the Danish Welding Society and Sibri. My name is Antonio Fernandez, and I will be presenting this webinar together with my colleague Jorge.
Hello everyone, welcome to be here today, and I hope we will enjoy the webinar.
Thank you, Jorge, and thanks to you for attending this webinar. The topic of today is going to be how the technology of augmented reality is helping to overcome the traditional challenges of welding training. In order to do that, in order to make this webinar, we are going to make a 10-minute presentation about this global problem and the technology that can help to sort out this problem. Then we will make a live demonstration of the technology that we use. Okay, this is the technology, and then we are going to have a Q&A session where we will try to answer whatever question you have. Okay, that we are going to do that live. Okay, as much as we can. Whatever question that cannot be answered in the moment, we will reply to you privately on an email as well. Okay. Please note that this session is being recorded, and we are going to send you the video afterwards. And also, you should find on the left side of the screen, you should find a section where it says Q&A. When you go there, you should be able to text, to write your question and to submit it. Okay, so we should be able to see it and then reply to you by the end of the demonstration. Right? ¿Puede darle clic en la pantalla? All right, perfect. So thank you very much to the Danish Welding Society for distributing and sponsoring this webinar. And thanks also for the members to supporting this. For those that don't know us yet, we are Sibri. Sibri is the leading company in the development of skills training solutions powered by augmented reality. And we are a company with headquarters in Spain and a team of more than 90 professionals distributed in more than 10 offices across the world, okay, in every single continent. We have a global presence nowadays, and today we are in the headquarters in the south of Spain. We're going to start with the reason to be here. The reason to be here is welding. And why welding? Welding because it is very important in our day-to-day life, and you all are in the welding industry, so you know what we're talking about. Welding is present in your cars, in your trains that you take, in the planes, in buildings, in your office. So definitely welding is a matter of importance during our day-to-day life. So important that it can be translated to terrible consequences if the welding quality is not according to the requirements of a project. And we can have a look at this project where this fact where Mr. Grosjean's car crashed because of a welding failure problem, right? None of us would like to have this kind of accidents, this kind of experiences. So definitely we have a quality problem in welding and qualitative problem in welding. But we also have a quantitative problem in welding, which is the shortage of welders in the world. According to the American Welding Society, we will have a shortage of more than 400,000 welders by 2024 only in the USA. If we took those numbers at a global scale, we will be talking about more than 3 million welders every single year. Okay, 3 million welders in the whole world every single year, and that's a lot. And the reason for that, the reason to have such a big shortage, is that we are not being able to replace the welders retiring fast enough. We are not being able to replace them with younger generation of welders. Actually, do you know what is the average age of a welder in the world? It is 55 years old. It is very adult. We have a very adult trade, and we need to get that number down. Only 20% of those are under 35, right? So that is a big problem. And technology is coming to help. Technology, we have welding robots, welding automation, so that it's going to take a good number of manual skills out, okay, in order to automate them, to make them more productive, and to shorten that gap. But we still need experienced welders that can work on complex structures, on maintenance jobs, on repairs. So we still have that problem. Actually, we have two problems. We have a manual welding gap, but also a robotic welding gap. We have people, we need more welders, we need more manual welders, but we also need people that know how to operate a welding robot and also that know how to weld, because they need to know both expertises together. And that nowadays is very rare. It's very rare to find someone that is expert in both fields together, right? So we have robotic welding and manual welding skills shortage at the moment. On top of that, we had a problem. We still have it, of course. The education system had a big issue with the COVID-19 when more than 190 countries had to close their schools overnight, right? This translated in the welding world on stopping the training of many welders, not only education, also industry with their academies and so on, also the upskilling programs that they had to stop training welders. So we have many schools that are closed now, many companies that they don't expect to open up until September, until January, and to try to sort that out, they are trying to digitalize as much as possible with learning management system, with video conferences, and so on. But welding training is very practical. It needs hands-on, right? And this technology actually can also help on that. We can do remote training to train welders with this augmented reality technology. This picture is very interesting, and we always like to show it because it makes visible very well the vision of the technology, right? The technology is not only used to train beginner welders, okay? It is used also for upskilling welders, because when you weld something in augmented reality before welding it in real, then you are increasing the productivity of the real operations afterwards, of the production line. You are reducing the quality problems that you're going to have afterwards. And this picture, you can see a car, you can see a welder welding in augmented reality just before going to the production line, right? This is actually a real picture. It's from one of our customers in Germany, an automotive company, one of the leading automotive companies. And this technology is supported by a methodology called augmented training. This methodology combines two different environments. The first environment is the one on the left, will be the augmented lab, which is actually where we are right now. Okay, you will see that we are surrounded by simulators here, and it looks like exactly this picture. This augmented lab is a safe environment where the students and welders, they are going to be able to train in a very safe way, very clean way, very attractive way. Okay, so this is going to be for the beginning of the training, where they're going to master the skills, their muscle memory, without spending materials, consumable gases. So it's going to make it very safe, very efficient in terms of speed. They're going to train faster than in the real workshop, because here the time on arc is faster. They can spend more time actually welding. It will be also more attractive and more green. Okay, it's going to be greener. We don't have any pollution or anything like that. Then once they know what they are doing, once they have mastered the skill, then they will go to the real workshop, which is actually the one that you can see behind those curtains. Okay, there we have a real workshop, and there they are going to finalize the training. They are going to make a few more welds. They are going to be supervised by the welding inspector, by the welding teacher, and then they will move forward in the program. Okay, so it is very important to understand that this technology is to be used together with the real workshop. Okay, the idea is not to remove the real workshop, it's to complement it. And if we take a look at this methodology that we're just talking about, we have three main elements. The first element is the top one, is the e-learning platform. That e-learning platform is a software platform where we are going to be able to digitalize the whole welding curriculum, okay, the whole welding training program, meaning theory contents, tests, exercises, students database, reports, everything, okay? That is going to be linked with the simulator, where the students are going to perform the practices that afterwards they're going to do in the real workshop. So the flow of information of the training is going to be that. E-learning, simulator, real workshop. That is augmented training. And this augmented training methodology has proven to have very good results compared to the traditional way to train welders. These numbers that you can see here have been taken from a real study done together with the Spanish Welding Society in one of the schools in the north of Spain, but there are many other studies similar to this that schools have done independently even, right? So at the end, the results are very similar. First of all, we are going to, as you could expect, have a more productive training in terms of cost, because we are not using consumables, we are not using materials here, and then much faster as well, much faster training, because we are shortening the learning curve. We're training faster those welders in order to go then to the real workshop. Okay, so in 1 hour, let's say that we can make 4 or 5 times more welding exercises than in the real workshop. Okay, then of course it will be very safe, because we are not using, we don't have gases, we don't have heat, and therefore also very green. Okay, environmentally friendly. Now, just before jumping to the real demonstration of the system, we want to share with you a nice story, a real story from one of our customers. This is a German Welding Society in one of their training centers in the north of Germany, where they received a group of refugees. Okay, this was about 50 refugees that they received from 16 different nationalities. So it was very challenging, because they didn't speak the language, they had no experience in welding, and they wanted to pursue a career in welding, because Germany needs welders and they need a job. So definitely they thought this could be a good chance. And the German Welding Society bet for this technology to use it in all the training centers. And especially in this case, they created an augmented lab like this, okay? And then the real workshop. So they practiced here. They did, first of all, a language class, okay, where they could get some basics on the communication. Then they spent a good time on the augmented lab, and then they went to the real lab. As a result, in less than 6 months, most of them, they got their international welding certificate, and the practical training time was reduced by 20%, with, of course, a reduction also of the cost. Okay, so they were very happy, both the training center and the students, because it was a very innovative way to train welders, and also very attractive, very motivational for welders. Okay, excellent. So this is the presentation that we wanted to share with you, and now what we're going to do is explain a little bit the system, especially now the hardware components that you can see here, and then we will talk about the software. Okay, so to start with, what you can see here looks like a welding power source, okay, because we are simulating a real welding power source. Here you will see the control panel, where we are able to manage the different welding parameters. We are able to change the voltage, the amperage, the gas, the wire, everything, right? Then we are using a welding helmet, but it's a little bit different. You will see that here we have 2 cameras, okay? These 2 cameras are the eyes of the system, and through these 2 cameras, we are going to be able to read markers like you will see in coupons and in torches like this, okay? And this is going to provide information to the system. You will see that we have a screen here. Through that screen, we are going to see through that camera, okay? Then we have welding torches, real welding torches. Actually, these ones are from Epic Vinso. And this is a very important element, because what we are training with is with real torches. It's not fake torches. It's not plastic. Meaning that the weight and the shape is going to be very similar to the ones that they're going to use afterwards, which is very important in order to train the muscle memory properly, right? So we have a Micmac torch here. Then we have a TIG torch here, together with the welding electrode, right? You can see that everything has markers. This is going to allow the system to track the torches, okay? And then also we have the electrode holder that can be also connected together with the electrode stick rod that you got, okay? Now, then we have the coupons, okay? The welding coupons, you will see that we have a group of coupons there, okay? Those are educational coupons. Those educational coupons are the ones used normally for certification, okay, for the standard welding training, international welding training certification of welders. And then we have advanced and industrial coupons. These coupons that you see here are a little bit more complex and advanced, as the name says, in order to upskill welders, okay? This is actually for competition purposes, for world skills, kind of. And then we have this one, which is for the automotive sector, okay? We have different verticals. For instance, we are developing one for shipyard now, and this is for automotive, okay? This is actually one of the coupon that the welder there in the image was welding before, right? So now, what we are going to do is, we are going to wrong one so that you can see what is the results. There we go. And this one. And then we get the score. The score is on a 100 scale, okay, in test and also in practices. So we can see that we did not pass, or sorry, we passed, but we had some mistakes. The first one was in the question number 3, where the correct answer was by shielding gas, and I selected by slag. Okay, so the student will be able to know, to get instant feedback from the system in order to perform, okay, faster. There we go. And the same on the last question. I chose maintenance cycle, and it was the correct answer were 2 actually, type of power source and welding processes for which the power source is suitable. Okay, so now I am supposed to repeat the exam in order to make the correct answers. We can look at this exam, exact same content in an online platform that the student can access on the computer, on the mobile phone, etc. Okay, Jorge, can we open up the student platform, please? There we go. So this platform, you will see that we are logged in with also with my student name. Okay, so I can see first of all on top of it the different courses that I am enrolled in, and then at the bottom we can also see the reports of my own performance in the system. Okay, let's open, Jorge, the DBS basic training GMO, for instance. That one, not the second one. That one. Oh, you need to log in again. Yeah, okay, open. Baja. Okay, go down. Go down. There we go. You have the GMO one. A little bit down. There. And then you will be able to open, for instance, the theory. Okay, there. There you go. So we will have access to this information in the simulator and also in the computer, in the smartphone, etc. Okay? Okay, perfect. Let's go back to the simulator. And now we are going to make a real practice, okay? You will see how augmented reality works out. In order to do that, we are going to configure an exercise from scratch, okay? We are going to make an open practice. Perfect. Now, you can see that we can configure the exercise in different ways. The first thing that we're going to choose is the difficulty level, okay? We have beginner, intermediate, and advanced. The more difficult, the lower score the system is going to give me, okay? So I'm going to choose intermediate, for instance. And then I can tell the system to show or not to show help icons. Help icons are going to help me during the welding. During the welding, if I activate the help icons, I will get assistance. I will get some information telling me how to correct my manual skills. If I disable them, I will not get any information, okay, any feedback. So I will enable them. Then we're going to choose the coupon. The coupon, we have education coupons, which are these ones that we talked about. And then we also have advanced coupons, okay, which are these ones that we showed you before. These ones, also you can find some of them at the bottom, right? So we're going to make the first one on an education coupon, on a T-joint. We can choose the position that is going to be also adjusted in this work stance. So we're going to make a PV position. We will choose the material, which can be carbon steel, stainless steel, or aluminum. Okay, so let's do carbon steel. We will make a 6mm thickness on a GMO. We can choose any of these processes, okay, as we discussed. The wire, the type of the wire, the gas, we're going to do mixed gas. We're going to do a 100 millimeters weld of one pass, straight, continuous, and we're going to push. This will be my WPS, okay? Which you can also upload your own WPS with your own template, structure, logo, etc. There we go. Now, what you're going to see what we see through the helmet, okay? So you're going to see, 1 second. There is some lag in the image, 1 second. No, está aquí, pero no está aquí. Espérate. Dame un segundo. There we go. Now you should be able to see the cameras. Right? So what we can see through the helmet is these QR codes. These QR codes are going to convert into a carbon steel T-joint that we are going to weld, okay? And you can see that we have some virtual elements that are going to help me, okay? They're going to tell me what to do, okay? Those are the help icons. And when I take my torch, you will see that this torch will activate also some help icons on the torch, green and red, all right? So I will need to make the whole welding, trying to make as much as green as possible. We are going to be working with travel angle, work angle, with the stick out, and when the color is red, it means that I am wrong. I need to correct my position, my manual skills, okay? When it's green, it means that it's good, so I need to keep it as much as I can, okay? So I'm going to first make a quick exercise so that you can see the effect. I'm going to place the microphone here so that you can see also the sound, okay? You can hear the sound. All right, so we're going to do from here to here. Right, you could see how I pulled out and then it became red, the stick out, because I was actually too far, right? And the same would happen where I actually pull in and I am just actually touching the coupon, okay? The system is telling me to back up. Also, when I make it faster, I will see also the effect that it has in the welding bit. So I can see how the welding bit is thinner, the penetration is going to be lower, right? There we go. Right, so when I take the coupon, I can even look at it. See, so let me just take the microphone. So when I see the coupon, I can see even welding defects, right? I can see porosity, I can see spatter. Okay, so the realism of the simulation is very high. We work with real welders, we have a workshop, and we parameterize the different weld scenarios as much as possible in order to have a very, very realistic experience for the welder, okay? There you go. Now we are going to have a look at the analysis module after this weld, okay? We're going to see the results of the actual weld, and we're going to do that in the analysis module of the simulator. So this is going to give information to the student about their performance, okay? So we're going to see different scores. First one is on the top left corner, which is 88. 88 on a 100 scale. meaning that I didn't pass because the minimum passing score was 90, all right? And that can be also adjusted. That 88 is the average of all the different scores that you have then on the right side, which is for the different parameters, for the work angle, for the travel angle, for the stick out, the CTWD, the travel speed, the aim, and then the welding parameters, all right? So when I look at this, the first thing that I see is some red, okay? That red here is the stick out and the speed. And the reason because it's red is because I got 81 and 71, lower than 90. And you may remember that I was actually playing with the stick out. I was pulling back and pulling in. So my rate there was lower. And also the speed. I was actually going too fast at the end of the weld, right? And I can replay that. I can see that in the actual 2D view here. And I can also replay that. So I can navigate through the weld. I can see what happened exactly when I was welding in the different positions, right? There you go. Okay, so if I want to see an exact point of the weld, I could just stop and I could see, for instance, here that I am too close. I am actually touching the coupon almost, right? There you go. All right. So this provides a lot of value to the instructor because they know also what the student has done, okay? What are the mistakes, what kind of advice to tell them, and of course to the teacher, to the student, to the welder, because they will know instantly how to improve. Now, if I want to improve this weld, I will repeat it, focusing on the stick out and the travel speed, okay? And this same information is going to be available also in the e-learning platform. The e-learning platform, if we can go, Jorge, we will see when we go to the student in this case, yeah, Antonio Fernandez, and here we will be able to see different reports. When we go to this exercise, open demo, we will be able, we can see that there is an exercise on the 9th of June at this time, okay? So we can open the actual exercise. This is in the computer, okay? This is, let's say, the teacher looking at the different exercises that the students have done, okay? So we can see actually a list of different exercises that Antonio Fernandez has done previously, okay? And this is today's exercise. This is the one that we just did, okay? A second. There you go. So we can see the exact same information that we saw on the simulator, but on the computer. Okay, that gives a lot of value. We can see the story of a weld. We don't need to see only the end of the story. We can see the actual story, okay, and interpret the results and explain the different welding defects and enrich the whole training, right? Okay, perfect. Let's make now a test on a little bit more complex coupon, which is this one. This one is for the automotive sector, as we said. Okay, so we're going to weld two segments. We're going to weld here, and then we're going to weld on this corner. Okay, here and here. All right. So I'm going to place the welding joint here. There you go. I will position the coupon. And then I will design my exercise. Okay, so I will make again another open exercise. Also, I will keep the guides and the intermediate. Okay. Then I will choose the actual coupon. Okay, this one. And here we can see that we have two different weldments. Okay, we have the A and the B. Then, as before, we are going to activate the augmented reality. There we go. And now we can see the first segment, okay? So I will make the first one. Note that we can also look at this exact information about the performance, not only in the simulator and not only afterwards. We can also see that real time, Okay, so I'm going to make a little weld, and my colleague Jorge will show you how the teacher in his computer, he will be able to see the actual performance of the students. Okay. All right, so I'm going to weld in here. There we go. Okay, it's not looking too bad, that's good. And then we're going to do the second one. The second one is a little bit more tricky, okay? Because I need to do from here. Then this one. Okay, so I have a little deviation here. This don't look too bad, that's good. Right. Perfect. So let's have a look at the analysis module and see the results of the exercise. There we go. So I got a 95 on the first weld. There we go, 95 on both of them. That's good. But I got some trouble on the travel speed, okay? The travel speed was too slow a little bit at the end. At the end, I had to go a little bit faster, right? I can replay that. There we go. Okay. Yeah, I was too slow there. And I went over a little bit the piece. Okay. Good. Excellent. So this is the two practices that we wanted to do today. Now we're going to have a look. Do we have any questions, Jorge? Okay. How do you handle volumetric defects? We work on spatter and porosity at the moment, okay? So the simulation of those defects are being done by taking real samples in a real workshop, okay? And parametricizing that into software programming for augmented reality simulation as close as reality as possible, both visually and also the sound, okay? The whole welding, let's say the whole welding effect, the whole welding bit is done like that, together with the defects. And we're going to be adding more and more defects as we go, okay? We don't have many more questions, actually, I believe. So if you have any further question, feel free to make it now. Otherwise, we can, thank you very much. We got some comments as a thank you, and very impressive too. Thank you very much. But feel free to contact us, okay? You have also our contact details. You have the Danish Welding Society contact details. This can help welding training centers and industrial companies also that employ welders and they want to upskill their welders, they want to do screening of welders, etc. So we will be very happy to help you out with this technology, okay? So in name of Seabury, we want to thank you, okay, and thank you to the Danish Welding Society also for this opportunity. We hope to see you soon and also at some point to be able to enjoy this technology together physically, okay, when we are able to travel again. Thank you very much. Bye-bye.